let's see an example now. So this is, the example is about Starbucks. Do you already know what Starbucks is? It's about coffee. I do like this. In Italy, coffee is this. In the US, where Starbucks is, coffee is like this. They have these huge cups, and they have thousands of different options. So if you go to Starbucks, the first time you say a coffee, then they ask you, oh, what coffee? And they say, yeah, I don't know, macchiato. Oh, okay, well, how would you, which flavor? Which flavor? Macchiato. You know, and they have like dozens of different flavors, and they say, ah, okay, caramel. Okay, caramel macchiato, with or without cream? Without cream. So, first time in the US, you go to Starbucks, try to order a regular coffee, you want to have this, and you come out with this. For sure. There's another shop, another chain, this is Subway's, where they make sandwiches. And you think a sandwich, very easy. You go there, you say, yeah, I want to have a sandwich. Then they measure sandwiches in inches, 12 inch, 7 inch, the length. Then you say, okay, 7 inches is enough. What would you like to have? Then they have menu. They say, there's the Tuscany chicken. And you say, oh, cool. Okay, I'll have the Tuscany chicken. And you think that's a recipe that is fixed? No. Because then they have all the different things, different salad and beans and sauces and salt and sugar and whatever you want. And they ask you for each of these. The same is with Starbucks. So, but it's about coffee. So if you go to the US, go to Starbucks and have a coffee. And then tell me whether you could really order what you actually wanted in the first place. What we want to do here is now we develop a simple RESTful web service that basically implements the order process in Starbucks. It's the order workflow. We make a selection. We may add specialties. As I said, specialties are the key in Starbucks. And then we pay. We wait for a while and we drink. So this waiting in Starbucks is the tricky aspect. So Starbucks is a huge success all over the world. And they have Starbucks, you find it everywhere. In China, all over the world you find it, except in Italy. So I read once a newspaper article by the CEO of Starbucks, where he explained that they are simply too slow for Italy. So in Italy, you go to the bar, and while you start saying what kind of coffee you want, there's the barman already doing it. So it's very, very fast. Coffee in Italy is extremely fast. In Starbucks, they take your order and then they write it down, and there are 5 different people who work on your coffee, and in the end you have to wait like 10 minutes and you get your coffee. It's just not a model that works in Italy. So the wait for a while is at least something that we don't do with the web service. Okay, let's see how we would implement this Starbucks service. Placing an order. We know the URL of our web service, Starbucks. So what we are the client, Starbucks is there, and there's the resource which is our order. It's not yet there, we want to create it. So what do? We place an order in Starbucks. What we do is we do a post on the Starbucks URL, and the order is the second part of the URL. So this is what I said here. This is exactly the order entry point. And here we do a post, order entry, and we say what we want to have is a drink latte. One of the options is latte. It's actually a coffee. It's caffè latte in Italian. What we get back is the response there, which essentially tells us, okay, order created. So now Starbucks knows that we want to have a latte. And then they give us some XML back. So this is what they created on the Starbucks server, let's say. First of all, it's an order. There's our drink. And then there's a link. And this, okay, maybe an API. We will look at this a bit later. We place the order. Now, mistake. They didn't ask us about the options. So I forgot. But I would like now to add something to my order. So I placed the order, they already took it. I went away from the bar. But then I want to have more coffee there. So I want to have some shot of espresso, additional shot of espresso. So what do we do in terms of the web service? We essentially would like to do a put on the order. We want to update the order and add the additional shot. But as I said, there could be the clash between the client and the server. So let's first check, for example, if we do the options, then we do the options on the order we got back. Oh yeah, this is maybe the information I forget to highlight here. Over there, the second part is the location. This is the URL of our order. This is what we need to use from now on in order to talk to our order. Here we do an options on this order URL, and we get back that we can do get and put. Get is when we are allowed to read what we ordered, fine. But we can put. Put means we can update it. Very good. So let's try to do it. What do? We do put on the URL. Starbucks, what is this? Put this in right now, exception failed otherwise. Before you leap. This is basically expect asking whether it is possible to update the resource. So here I do a put, but before actually doing the put, I asked whether it is possible. So in this case, the resource has not been updated, so I can really update my order and add the additional, how is it called? Addition? The shot of espresso. So how do we do, what can happen here? Let me check whether this is what I want to explain or not. Yeah, okay, so we are, as said, here. What we do before updating the order, we check with the web server whether the order is still available for updates. Because if they already did the coffee, then ciao, and it would be with only one shot. So with this here, expect 100 continue, 100 continuous response means, okay, the order is still open, you can work on it. Then let's do the update, which is basically we do a put on the URL of the order, and we send the representation, the XML representation of our order. Now, however, with the extension of the addition of one shot of espresso. All the rest is the same as we got back after the first post. Now we have this here, and what we get back is 200 OK. The location is the same, so I was still in time to update my shot, and here, as I say, the payload is just essentially the same as I sent there. This is just a confirmation, but the web service is telling me, okay, you successfully updated your order, there will be one shot of coffee more. Let me just go. Yes, statelessness, this is what we already explained. So what could happen if we were just too slow? I said we placed the order, and they started already doing the coffee. We are too slow, we want to update the order. It would not be possible to update the order any longer. So in RESTful terminology, what could happen is this. We try to do the put on our order, and what we get back is a 409, a conflict message. So something has happened. So let's understand what happened. What we can do is, again, we look, as I said, something goes wrong. Either you try again, but if you get 4 times the 409, then probably there's really a conflict. Then what you do, you need to explore what's happening on the web server. So you use the options on the URL of your order, and you see that now you only get as an option. If we go back, remember here, with the first try, we got get and put, meaning read and update. Now, we were a bit slow, we can only read, we can only get. What does it mean? It means that the order has been processed and it's no longer available for updates. Very simple. So what can we do now? In our case, we we were able to change the order. So if we do a get on the URL of the order, just to check what is there, we get this back here. And this is again the payload. This is the representation of our order on the web server. So now, okay, we have the order, we have the addition of 1 shot of espresso, we have to pay. Okay, and now we can start thinking about this link here. The link essentially tells us that this is the rel relationship gives meaning to the link. It tells us that this is a link that allows you to do the payment. And then the href is the URL and the type application XML. So you can send XML to this link, and this means that you will be able to pay for the order. Of course, in order to do this, you need to know how the XML must be formatted. So somewhere in the description of the service, you will get the XSD of the XML message that this link accepts. But what we want to do now is we want to pay. So paying means we need to talk to a new resource on the web server, which is the payment resource. We have the order resource, we have the payment resource. They are independent, they are just interlinked. And in essence, we want to, how did I know how to put? Okay, this is the same play as again as before. We do on the payment URL, we check what we can do. We can do get and put. In our case, get is not enough because we want to really do something, so we do a put on the URL of the link, and this looks like this. So paying with our Starbucks service is essentially issuing a put on the URL of the payment for our order with content type XML. The format of the message we need to read from the documentation of the service, but then this is what we send: payment, card number, expires, name, amount, and so on, payment information. We put it on the URL that we found in the link, and the server answers back with the 201 created and with the payload here. So essentially, it tells me that the payment was successful. So for example, this was $4 here. If we just put 3, then probably the server would answer with some error message and tell us that there's not enough money. So there could be also error messages in the body, but this is in this case everything went okay. Now we want to be sure, as we said, we never know what happens on the web server, so we want to be sure that we really paid. So we do simply a get on the order, and now the order resource should look like this. Before the payment, the representation of the order contained also the link to the payment. Now that we paid, the resource doesn't care any longer about the link to the payment, and it's no longer there. So we are ready, I think, to get our coffee and to drink. So this is a very small example of a RESTful web service. Any questions? Yeah?
How is it set in the server side that you cannot update it? I mean, you try to update, but you don't have it.
Yeah.
How is this?
The example?
Yeah, no, I mean, how is this set? I mean, what is done in the server side that you cannot update it? I mean,
Yeah, on the server side, so in practice, if we talk about Starbucks, you make the order, they start doing the coffee. So if they already have the ready coffee there, and then you come and you say, oh, I would like to have another shot,
I mean,
then of
protocol, I mean, in terms of HTTP now.
Yeah. So this is what happens with the resource. And then in terms of HTTP, the protocol is always HTTP. The protocol is you do a put on the resource, and then it's not just the web service. The web server as you have it for regular websites where you only manage HTML pages. If you do a RESTful web service, you have some more sophisticated logic that the developer of the web service implements that is able to understand okay, there's a client asking for a put on the resource of this order. Then the internal logic will go and check whether the order is still available. So in essence, this means probably when you do the post and you create the order, you will write an entry in the database. Then when somebody in Starbucks starts working on your order, they will flag it as processing, for example. And then you come and you ask for an update with the put. Then before the web server accepts your put request, but then the web server hands the request over to a piece of code. That piece of code then goes and checks in the database whether there is the processing flag or not. If not, it updates the entry in the database and sends you a 200 OK message back. If instead there is the flag of processing there, of course it does not update anything and it just sends you back the whatever error message. I don't remember, the 409 conflict message, for example. So this is, it's not the protocol. The protocol is always HTTP. The error messages are the standard error messages. It's just that you talk to a remote web server. The web server passes the URL. Based on the URL, it knows how to forward the request to which piece of code. And then it's that piece of code that manages the internal logic of how to handle the request. Yeah. Okay, so I also have the mouse here because I wanted to sum up this a little bit. Let's see. We have still some time. Yeah. I'm no longer used to draw on whiteboards or so on. But what we can do, we are IT guys, so we draw. No, actually, I don't want this. We do a new one. Going to be a bit tricky. So to sum up a bit what we did here. Okay, we have some space. Let's put this a little bit away. Good. Okay, so let's try to model this world of RESTful web services. We start with the trivial thing, resources. Let's kick out this shadow things, useless. We have order, for example. Let's make it like this, order, and then we, oops, sorry, we may have drink, and we have payments. So this is, it's really like data modeling. If you want to do your own web service, you need to understand what you want to talk about. In this case, we have orders, payments, and drinks. So in the example before, we didn't talk about the resources for the drinks, just for simplicity, but you need to have them there, otherwise you don't know how to place an order. If you don't know about the resource drink, that was the latte entry, then you could not place the order. Next, we said orders, they may link to drinks, and they may link to payments. Okay, this is more or less the information model of our very simple web service. Now, what else do we want to do here? We said that you never have access to the actual resources, right? You only get representations of them. So some XML stuff, for example. Or let's make this a bit smaller. So what representations can we have of our order? We have XML, then we have maybe some JSON, up, a bit big. What else? The drink, how does a drink look like? Again, we say we have an XML representation of it, we can have a JSON, and if you want, we can have a JPEG. I give you a picture of the latte, or I give you a picture of the caramel macchiato. And for the payment, we just place XML. And they are, of course, linked in a sense. Up. Where is this? Thickness. It's always the same. No. Let me take this one. So we link the resources to their representations. And these are the artifacts we talk about. So imagine the resources now placed in a database, and the representations is, when you develop this service, is what you need to generate as response to the clients, to the customers interacting with you. So how do they interact with you? They write a URL somewhere. So let's put a box around this. Stroke, I don't know. Stupid shadows, they are just boring. Let's put this into the background. So we have, we can also drop the fill. So we have one box here. Then we have another box, another box here for the payment service, for the payment resource. And here we have the drink. Let's take everything here. We have another box. So, and what do? We can assign a URL to this. We have a base URL, whatever, http://starbucks.org. I guess it's a com, they make money. Starbucks. So this is somewhere on top. So this is what we use as starting URL. But then here we just add the /order. /order. I'm not able to write. So we talk to the orders by using the URL http://starbucks.com/order. The same we do here for payment, and here for the drinks or whatever. Yeah, drinks. So these are the URLs. So now we have the resources, we have the URLs. We miss the operations to actually do something with the resources. Let's just, I always need to start from 0 here. Not good. Doesn't work. It's always in the wrong place. So from here, we go here. Fill. No. This one I want to fill. And we say we have a get entry point here. With the order we saw, there was get. Of course, we have a get everywhere. Let me put or represent operations like this. They are entry points to this box here. The box is the resource with the representation. Then what else do we do on the order? We saw we wanted to do also the put on the order, at least. And we did also the post, right? I only put now here for simplicity, let's say the CRUD operations. We don't need to put everything. Otherwise it gets a bit messy. For the drinks we are fine if we have only the get operation. And for the payment we had the get and the put. Where do I put them? I can make this like this. We have here a put and we have a get operation. So these are the entry points. Okay, so if we do now post on the order, we create an order and we get an XML back. So how do I represent this? So we can say we do post. No, let's start from here. We do get on drinks, and what do we learn? We get, not the whole box, this should be in the background. We get an XML back. We did it on the orders. What do we get back here from the drinks? Probably we get back, we discover that there are 3 types of drinks there. So we have drink 1, let's call it like this, drink 2, drink 3. So these are links, and the drinks are here. So we have here a set of drinks now, which we know, and here we have the response that tells us that there are 3 different types of drinks. Okay, we can now, for example, do a get on drinks, and as I said, there are links here. We interpret the link and we do drinks / we identify now the drink that we really want to get, drink 1, for example. So we do a get on drinks drink 1. This is drink 1. What do we get back? We get back the XML. We get back the XML that is now the drink 1, D1. Drink 1. Let's use capitals for the real resource, or for the payload we are interested in, and here the small letters only for the links. So now we know that there's a drink 1. Oh, sorry, the drink 1 actually is, let's call it the latte. That's what we had in the example, right? We had a latte there. Now, let's place the latte order. Why did I do this? As I said, before it was simplified. We already knew that there is a latte order, but in this case now I played the whole game. So I say that I don't know which drinks are there. I want to say that there's a latte here without the final one, and this here would be latte, and string 3 would be latte. Okay, now let's create the order. What do? We do a post. This we can kick away. We do now a nice post on order, and what do we send? We send a copy of the latte. So what does the server do? Oh, sorry, actually this goes here, meaning we do a post on order sending latte. What we get back is a piece of XML containing what? Containing our order 1. I don't know, I hope you can read this. So we get back the order, which contains the confirmation of the creation of the order 1. It contains a link to the payment. Pay 1. And what else? Just the payload is the copy of the XML of the latte, for example. I think that's more or less what we need here. Then, more importantly, we get back also the order 1 here. It's the confirmation, but it is, but it is the URL of the newly created order resource on the web server. So we are going to have here the order 1 resource created in this entity, so in this resource. And probably if there's a pay 1 link, and we can work with put on the pay 1 link, then the web service here already created automatically a pay 1 resource for the payment, and they are linked. Okay, now what did the guy in Starbucks do now? He tried to update the order, which is essentially put again on order. So let's we do a put on order, but now we need to talk to the right order, our order, which is order 1, and he had the update latte plus. There was the shot of the extra shot of espresso, and then we got an OK back. I don't remember, but essentially we get the same message back, which means okay, the server updated the order here, and we are going to get the right latte with the extra shot of espresso. Finally, the payment was done by following this link here. How do we pay? We do a put on payment, but we know which payment. It's not a generic payment. We have it in the link here, so in our order resource, it's called pay1. So we go here, we add pay1 put, and then here we had the, I don't know, there was this XML representation of the payment, and it was successful, and we got essentially the same message back. But you see, this is the logic of what happened. And now, the key concept here I was always talking about is state and links, right? So the links, you see, they are very important because they link the different resources, and that they allow you to navigate through the resources. And what else do they allow you? They allow you to create your local state. What is your local state now? Your local state is this here. You have this, 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 this. I don't know, fill red. All this stuff is what you fetched from the web server, and you have it on your local machine. You are the client of the web service. This tells you what you did. So we went from the get on the drinks to getting a representation of the latte. From there, we decided we would really order one of these latte. So we did the post, and we created the order. We went from the order to the, what was this? We did the update on our order, and then we paid, and hopefully we got the drink back. So all these interactions, so all the representations that you got back with the links included in the representation are your application state, and this is your interaction with it. You could have taken a completely different path. Yeah, each one has a different interaction state with the web service, and this is important. This is all client side. So here there is this line above. This is the server, and this is the client. And you see, the server doesn't care about keeping state. So state in this case here is all the red things. It only creates resources, and resources, they don't know anything about you, only when you interact with them. This is key in the web. It guarantees the scalability, it guarantees the robustness of the web. You see it with websites, and this is the same logic that you then apply when you want to develop RESTful web services. Just to extend this a little bit, the picture, let's kick these nice things out. Next time with Marchese, you will essentially see how to develop the bigger web services. Bigger web services that have a different level of encapsulation, and essentially they do this. We have the same Starbucks service, and you put, let's say, a big box around. Again, I hate the shadow. And yeah, let's keep it like this. So there's a big box around. You talk to the big box just with the entry URL. And what's inside the big box? The big box offers you, this is the traditional programming of APIs and traditional distributed computing. What you will do is you will create, as we did here with the get, put, and post, you will create your operations of your API. How does a traditional API in Java look like? You would have here, let me put this fill, get drinks, for example. If you have a class in Java, you would call it, I don't know, Starbucks.getDrinks. Okay? What else did we do? So we did get drinks to understand what drinks are there. Then we said create order. We created the order. Get drinks, if you don't give an input like an identifier, it just gives you all the drinks back that are there, which is the get, the plain get on the drinks URL here. You get the set back. If you do drinks slash identifier, you get only a specific drink back in REST. Here, when you implement these kind of functions or methods of a class, how do you do it? If you say there is no identifier specified, you get all of them back. If you pass an identifier, then the get drinks will give you only one specific drink back. Then for the order, we have a create order. And then what do we have? We have, of course, the get order, if we want to read what is there. And we have the update order. We want to add the extra shot. And for the payment, how would this look like? Probably we would have pay order somewhere. Let's put them all at the left side, just for convenience. Okay, so this is more or less the traditional API, right? You have one big API or library that gives you a set of functions that have domain-specific names and domain-specific meaning, and you have to read documentation that tells you what these different functions do. This is fine. It's traditional programming, essentially. But there's the difference. Where's the state now? So this is what I want to show. And this is then the difference between what we did in these last two classes and what you will do next. State, of course. You always need to keep state on the client side, because as we had before, we had different representations of resources. The set of XML files I highlighted in red, they are still there somehow. When you interact with this remote service, you need to know what you do, of course. The difference here is that now also the service might have to track the state of your interaction with the service. You may ask why. Very simple. If you do a get drinks, no need to think much about what to do. You just go straight from the go drink. Can imagine that you access the drink class here and you send back something. Fine. Create order, also more or less fine. You create something. It's independent of what you did before. It assumes that you send, together with the create order request, that you send a correct drink. Otherwise it will be an error, but it's not a problem of the service internally. But when you do a get order, and when you do an update order, or when you do a pay order, this assumes that at least there must be an order there. Otherwise there is an internal error, right? So you see, it is the service itself that might have, it depends on the kind of service you implement, and it depends on how you implement it and so on. But in general, this kind of implementation may require the service internally to check that what you do makes sense. So this, in essence, this is it's a state machine. So we can try to draw this. State machines are always bubbles. So let's use bubbles. This is our entry state, and state machines have an entry point. Okay, how do we call this state? No order. So we are in a state where there is no order placed by you. Let's just talk about you. Let's forget about managing multiple users and so on. It's just you. We are here. Then, in this place, what can you do? You can do get drink, and you get the drinks, right? So from here to here, this is not. We can do get drinks, get up. Oh. Get drinks. So as long as we do get drinks, nothing happens. We stay there and we can do it without any problem. Then what happens if we do the create order? We go to a new state, because now imagine we have the same resources, we have the same entities in the database. It's just that right now only the, let me put this here, fill, only drinks are there. You do a create order. Let me just copy this. You do a create order. Oh, up. Create order. And now you go into the order created state. Order created. This is no order. And now we are in a state that is called order created. Order created means we have at least one order here. We are green again. No. Now we have an order there. And the order contains at least one of the drinks, because this is part of the create order request. Okay. So we can of course again, in this state, we can of course again do the get drinks. No problem. But what else can we do here? We can always, the order is there, we can do browse new drinks. Maybe we want to browse them because then we add new orders. Okay, so we can add new orders like this. Okay, this is too much. It's not called add order, it's called update order. Up. Update order, and we stay in the order created state. Fine. So we manage this create order, the create order, the get order. Okay, man, the get order. Now we can do also the get order. Let's do it properly. Okay, we can have the get order. Up. Get drinks. Get order. Okay. So as long as we do get drinks, get order, update order in the state order created, we stay there. The only thing that we can do now to move on is we can pay. Paying causes us, however, to go somewhere else. We create a new state, because in this state now we do not only have the order created, but we have the order paid. And how do we get there? By using the pay order operation. So pay order, and we go here. You see, this is, if you implement this big remote API, this big web service, or what it could, the same holds also if you implement a local Java library or whatever class. You might have internally to manage this logic. So that's the key. So in the REST world, you dump the management of the state machine on the users of the RESTful service. And you do this by interlinking resources and by sending representations that carry the necessary links that allow you to go through the different through the graph of representations. In this traditional kind of API here, where is the graph? There's no graph, there's no links, there's no hypermedia. That's why you have the state machine, and it's the state machine that is the graph that you do. So what did we do? We did we started here. We did a get drink. Then we knew the latte. We did a create order. After the create order, we did an update order. And then we did a pay order, and we got our drinks, and we were happy. So the graph that is the state machine in RESTful services, in the web, in websites, is encoded by the hypermedia. And the thing here with the regular service is that, let me copy this as PDF, delete, paste. Now, as I said, in this kind of implementation here, how do I do this? Select this. We need to implement the state machine as part of the service here. And instead of having the links here, we have state. So the big service with the traditional kind of methods might internally have, might internally have the need of knowing, first of all, the kind of state machine, which is what you can do when, and it might have some kind of internal data structure or so to keep track of what you do. So this is the session identifier, session names, and all these information. This is a bit the big difference between this REST world, which is really based on the very basic web architecture and the very basic protocol of the web, which is HTTP. In the next classes, you will see how to put the box around and what it means to put the box around. And there are benefits also of putting this box around, of course. When it's a new level of abstraction on top and it has different guarantees, it's not bad. It's just you need to understand when you develop whether maybe this world is enough or whether you really need to have the complexity for all these big web services. That's it, I think. That's the message of today. And again, questions, whatever, either now, via email, or next time you ask Marchese, which is for sure he knows also the right answers. Okay? Good. Thank you.